Good morning. Today we learn class 9th physics. The name of the lesson is motion. And our today's topic is acceleration. Suppose there is a body or car and it is moving with such a speed. Okay. The speed is 40 km per hour. This is a car moving from point A towards point B, and the distance between these 2 points is suppose 40 kilometer. When the car reached to point B, its speed increases and its speed became suppose 50 kilometer per hour. Okay, 50 kilometer per hour. Here the increase in speed or increased speed can be said as acceleration or accelerated. From here we can make a definition of acceleration. When the velocity of a body increases, then we can say that the body is in acceleration. Okay, where the body increases its motion, here the velocity or the speed of a body is increases. Here it will accelerated or increased speed. Acceleration of a body is defined as the rate of change of its velocity with time. So from here we get the formula acceleration equals to change in velocity upon time taken for that change. Okay, for change. This is the formula for acceleration. What is change in velocity? Another question arrive in our mind. Change in velocity What is change in velocity? Final velocity subtracted by the initial velocity. Okay. So here you can write final velocity subtracted by initial velocity. When we take the above example, the final velocity is 50 km per hour and the initial velocity will be 40 km per hour. Okay, so change in velocity equals to 10 km per hour. From here, there should be some change on the formula of the acceleration. So again, the formula acceleration equals to change in velocity equals to final velocity subtracted by initial velocity upon time taken. Time taken. Suppose the initial velocity of any body or car is u and the final velocity is v. The time taken is t. In that case, the acceleration should be equalized to suppose initial velocity of a body is u. Suppose the initial velocity of a body is u and it changes to a final velocity v in time t. Then we can write acceleration should be represented by a equals to v minus u upon t. Okay. Where a equals to acceleration of the body and v equals to final velocity of the body u equals to initial velocity of the body. T equals to time taken for the change in velocity. Okay. Then another question arrive in our mind. What is the SI unit of acceleration? So here the SI unit of acceleration here there should be velocity. So velocity will equalize to meter per second, time second. So it became meter per second square. So here you can write meter per second square. Okay, meter per second square or meter per second square. Both are same. If they have given us the speed in kilometer, then it became kilometer per hour square. Okay. Then another question arrive in our mind, whether velocity is vector or scalar quantity. There should be some displacement in the car. So acceleration is vector quantity. We already know about vector quantity because in the previous video we learned about vector quantities. Okay. If those students who do not understand what vector quantities has direction and magnitude as well as. Okay. So uniform acceleration. When the velocity of a car increases, the car is said to be in accelerating position or accelerating. If the velocity increases at a uniform rate, the acceleration is said to be in uniform acceleration. A body has a uniform acceleration if it travels in a straight line and its velocity increases by equal amount in equal interval of time. Or in other words, you can write A body has a uniform acceleration if its velocity changes at uniform rate. Uniform rate. Okay, both are same. There are some example of uniform motion. The motion of a freely falling body is an example of a uniform motion because the resistance will be negligible at that time. Another example, the motion of a ball rolling down an inclined plane is second example of a uniform motion, uniform acceleration. Third example, the motion of a bicycle going down the slope of a road. Here are two things will important. When the rider is not pedaling, first thing, the wind resistance is negligible. Okay, this is an also important example of a uniform acceleration. Then another non-uniform acceleration. Non-uniform acceleration. A body has a non-uniform acceleration if its velocity increases by unequal amount in equal intervals of time. Okay, or in other word, you can write a body has a non-uniform acceleration if its velocity changes at non-uniform rate, or you can write a body has a non-uniform acceleration if its velocity changes at a non-uniform rate. Both are same. It depends on you which you want to learn. Okay. Then another word come into existence, retardation. What do you mean by retardation? Suppose there is a car. When the acceleration takes place, the velocity of a car get changes. Okay. The velocity may be increased. If the velocity increased, we can say that it is acceleration. If the velocity is decreases, then it should be retardation or declination or negative acceleration. Okay, so here we can write if the velocity of a body decreases, okay, the acceleration is negative. Or the negative acceleration is known as retardation. Okay, see that the acceleration is uniform. Then the average velocity at that time is the arithmetic mean. Okay, the arithmetic mean. The average velocity should be represented by v like this. There should be some line on that one. Average velocity, you already know about that one, arithmetic mean. Equalized to initial velocity added with final velocity upon 2, or you can write v bar equals to u plus v upon 2. If you like this video, like it, share it and subscribe it. Thank you.